Hey, hi everyone. A very good evening. All right, so let's get started with today's agenda. What we need to do today. So, this is the agenda for today's session. We'll introduce the object oriented programming a little bit. Right, we'll discuss what is object oriented programming, where it is used, what are the languages which supports the object oriented paradigm. Then we'll understand what are the classes and objects. Then we'll see in hands-on way that how we create the classes in Python and how we implement the further concepts in object-oriented programming using Python. So this is our agenda today, guys. Let me just talk about object-oriented programming a little bit. So when I talk about the programming languages, right, they are made to solve any programming problem. So we have a problem, and the way you deal with the problem, right, how you solve it is nothing but called as paradigm. So basically, we have two paradigms in programming languages. First one is procedure oriented programming. That is called as POP in short. We call it procedure oriented programming. And second paradigm, which is very popular, is nothing but object oriented programming. So now I hope you're getting a little idea about that. Object oriented programming is nothing but another paradigm followed by programming languages to solve any programming problems. So what's the difference between these two paradigms, which are very popular nowadays, right? Let me just tell you about that brief. Although we discuss these things in really details, all right, but let me just give you an introduction to that. So when I talk about procedure oriented programming, it is nothing but when we focus on the steps or the procedure to complete any task, right? That is nothing but procedure oriented programming. We focus on the procedure. We focus on the steps. Let's say if I ask you to calculate factorial of a given number, then what you can think about the solution of this problem, you will see that, okay, I will need a number, then I have to calculate the factorial, then I have to display the result. These are the steps that you need to follow. So if you focus on the steps that you need to opt, there is nothing but procedure oriented programming. Guys, this is just a brief introduction to procedure oriented programming. This is even more than that. But I hope you got the idea that in procedure oriented programming, we focus on the procedure. But on the contrary, on object-oriented programming, what we do is we focus on objects rather than the procedure. Let me just give you a complete example. Let's say if you go to an ATM and check your balance, there is a steps that you need to follow. You need to swipe off your card, then you need to enter your secret PIN, and then you need to choose appropriate options, and you will get the balance. Let's say you're checking balance in your account, all right? So what is this? These are the steps that you need to follow. This is procedure oriented way. But now, if you think about the same problem in object oriented way, then we'll focus on the objects which are involved in this operation. So which are the objects which are involved in this operation? That is nothing but the customer itself, the ATM machine, and the bank server. So these are the objects which are involved. And then we'll think about what functions they are doing. So this kind of approach, this kind of thinking behind the scene, or you can just say when we talk about the solution to the problem in terms of objects, then we call it object oriented programming because we are oriented on the objects, not on the procedure, right? Which we need to adopt afterwards. But let's focus on object first. And let me just tell you why we need object oriented programming. See, when I talk about smaller problems, then probably procedure oriented programming work for you. But when I talk about industry level problems, when I talk about bigger problems, which do not have any fixed and defined steps that we need to adopt to get the solution, then we go for object oriented programming. So in a nutshell, procedure oriented programming is good enough for small and moderate level problems. But when we talk about industry level problem, enterprise level problems, then we need to adopt the object oriented programming. Now, you must be wondering that which programming languages follows which particular paradigm. Yes, let me just tell you about that. So, if you talk about the programming language, which is like old school programming, like C, and if you talk about Visual Basics, these were the programming languages which were following procedure oriented programming. But the modern languages, which are like Java, C Sharp, Python, right? The PHP, the latest version of PHP is completely object oriented. And so, what does it mean? They are following object oriented programming as well as procedure oriented programming. It doesn't matter that they are only following object oriented way. And if we specifically talk about the Python programming language, it is not completely object oriented, but it follows all the important concepts of object orientation. So if I talk about the languages, then if you talk about C, VB kind of languages follows procedure oriented programming. But Java, Python, these kind of advanced programming languages follows both paradigm. Like you can also code in procedure oriented way and as well as object oriented way. I hope you got the idea about the things that we are trying to understand. Now, when I talk about object oriented programming, there are concepts that we need to understand. First of all, as we call it like object oriented. So we need to understand what are objects. Then we need to understand the concepts of classes. I'll tell you what is classes. Then we need to understand the basic concepts of object oriented programming like inheritance, encapsulation. So let's start with the first thing that we are trying to understand. That is classes and objects. So if I talk about the concept, which is nothing but classes and object, let me just discuss it with a very simple scenario. Here, when I talk about the objects, can be any identifiable entity, right? Like it can be customer, it can be student, it can be any electronic device, it can be anything. So when I talk about objects, they are runtime entities which are moving. So here, if you can see the diagram, there are three people, Sarah, John, and Jessica. So there are basically three objects. Can you just see object one is Sarah, object two is John, and object three is Jessica. So here, these objects have certain characteristics, like the name, maybe age, and their salary. Are you getting this? So what we do is we have certain characteristics of object, but those characteristics are actually defined in classes. So here, can you just see these objects have certain characteristics? Getting that? Certain characteristics like name, age, and salary. But let me just tell you, instead of defining the object each and every one at a time, what we do is we create class, right? And that is why the definition of class says that class is nothing but template of objects. So what we do is we create a template in terms of class for the objects. So what is the template that you need? So here, can you just see employee is the class. The name of class is nothing but employee. And you can just see there are three properties, name, age, and salary. You can just check it out. So these properties are defined in class. And when we create objects out of the classes, so here we define the characteristics in the class and then we create objects. And can you just observe? All the objects are having similar characteristics. Why? Because they all are employees. Now, when I have a template, can you just observe all the objects made from the class are having similar characteristics? All the objects are having name, all the objects are having age, salary. There are only three objects. You can create n number of objects from the class. It's a kind of mold, right? And we can create n number of objects from the class. Let me just give you the definition of these classes and objects for the formal way. Yeah, so can you just see, I have already told you class is nothing but a blueprint from which specific objects are created. Getting it? So here, if you can just see this example, here class is defined like the name, like employee, and there are three characteristics. And objects are created from it. So basically class become a blueprint for specific objects. Getting it? And if I talk about the components in class, there are three typical components, right? This seems to be a little complicated for beginners, but let me just tell you in a simple way. Like, can you just see class has got class variable, instance variable, and data member. So what are the class variables? Class variables are nothing but the variables. See, variables means a container in which you store the data. Every object has got its own data, but sometimes we need some data which can be used by every object. This is a kind of common data which can be used by every object which is created by the same class. So class variables are nothing but the common data which can be used by all the instances. Don't get confused the instances of the class. It is same as objects. Okay. When objects are created, the memory is being assigned, then they become instance. All right. So instance and objects are same thing, very thin line difference, right? So can you just see class variables are nothing but shared variables, right? Shared data. Then instance variables are object specific data, right? So you can just check it out. Here we have object specific data. Object one, the name is Sarah, the age is 37, and salary is 10,000. Object two has got specific data like John, 43 is the age, and 21,000, right? I made it a little bit high. All right. So 21,000 is the salary of so basically instance variables are specific data related to objects, right? I hope you got it. And the data members are nothing but the data which is associated or held by the class and objects itself, right? So I'll tell you with the code example, then only you will get the complete scenario. All right, here it's time to move into the code and let's see how the classes are created in Python. So we are talking about the object orientation in Python. So we'll see how we create the objects, how we create the classes in a hands-on manner. All right. So let me just jump into my Jupyter notebook so that I can tell you how we create the classes in object, right? So this is little weird example. Let me just give you one more. Yes. So this is a good example. You can just check it out. Okay. Okay. Yeah. So you can just check it out this example. No problem. You can just see there's very easy syntax that you can use to create a class. Now here, can you just see here the first line of the code is nothing but, let me just zoom it a little bit so that you can see that. Okay. So it's nothing but the class. So class is nothing but a keyword that we are using to create classes. All right. So here the keyword tells the interpreter that, yes, I'm going to create a class. And here Python is nothing but the name of the class. It can be anything. That depends on the scenario in which you are working with. So basically, you have to give name to the class. All right. So here, can you just see class keyword and then the name of the class and this colon. Don't forget this colon because this is nothing but containership in Python. Basically, this colon tells the interpreter that something is inside this class. All right. So here, can you just see this is the definition of the class. Here, the first line which I am giving is nothing but called as docstring, right? Docstring is nothing but a string which is used to give information about the class. So basically, what is this class is all about, right? So assuming that your code can also be observed by any other developer, then this docstring can help the other developers to understand what is the purpose of the class, how many variables are there, what are the functions that are included here, right? So that things you need to understand. Just to save time, I am presenting pre-written code, right? You can write your own code. That is completely okay. So just to save time, because there are a lot of concepts in object-oriented programming, I need to show you all of them. So that's why I'm saving a little time. All right, here can you just see this is nothing but a variable. A very simple way to create a variable in Python. Just name the variable, and if you want, then have some values, right? So here I don't have any value right now, but that's why I have a blank double quotes, right? That means I'm going to have a value inside it after some time. So here nothing but empty variable. Here can you just see beyond that is nothing but a method, right? Method or a function. If I talk about the definition of a class programmatically, there are only two things in class. You heard it right. There are two things in class. First, member variables. That means which contains the data, like the name that we have. So name is nothing but a member variable here in the class. All right. Secondly, you always have a member function, right? What do you have? You have a member function. Getting it? So here the member function name is nothing but method one. All right. Here there are a couple of attributes that I have passed. You can also call them parameters, no problem. So here I have a self, and self is nothing but a mandatory parameter when we define a function inside a class. You can just check it out. This function is defined inside the class. All right. So whenever we define the function inside the class, then we need to have a self as a mandatory parameter. I'll tell you what the self means. All right. So now, and name is nothing but the parameter that I have already declared as a variable. And here I've just printed a statement that hello Python, welcome, and the name of the person, right? A very simple class definition. You can just check it out. Now, as I have completed the definition of class, it's time to create some object. So how we create the object? Just check out the next line. This is the way you can create the object, right? What you have to do is you just have to name the object, right? And equal to the class it belongs to. Obviously, the object will be created from the class, right? And the class with the parenthesis. There's a reason behind this parenthesis. Let me just tell you. So here, can you just see OB1 is nothing but the name of object, and Python is the class name. You can just check it out. The class name is Python. So OB1 is nothing but an object which is created out of the Python class. And you can just check it out. This is nothing but a very simple way to create objects. So with this step, you have created an object of Python class. Now what you can do using this object, you can call the member variables, you can call the member functions. So let's see how we can do that, right? Can you just see ob1 dot method one, which is nothing but the function of the class, right? And you can just check, this is the value that I have provided. There's nothing but Ajit, right? Are you getting this? What does it mean? If you remember, there are two parameters in the method one. There is self and the name, right? So here I need some value against the name variable, right? Self, I'll tell you what is this self, don't worry. All right. But right now, just talk about the name, and you need some value against the variable name. All right. So here I have passed the value Ajit. And when I talk about this variable, it is going to be stored in this name variable. So here I just call the method one using OB1. As I have already told you, you can create n number of objects once you have created the class. So you can just check, I have created one more object. You can just see OB2. So OB2 is nothing but another object of the same class Python. So as I have created one more object, I can create the method again. Can you just see? Right. So OB2 dot method one, same method I'm calling with another object, right? I have passed one more value, that is Raghav. I hope you got it. Now let me just comment this and let me just run it for you so that you can see the object. Yeah. So can you just see, once I have called this method one, it's going to display the message like hello Python, welcome, and the value of name. So you can just see I got the outcome and the value of name right now. When I talk about object one, so it is nothing but Ajit. Can you just see I got Ajit, right? And when I call this method one against this object two, which has got a value Raghav, so I got Raghav. Can you just see? I mean, this was a very simple example that I am trying to give you, right? But here you can just understand the class is being declared, right? There are some variables, there are some functions. Now, as I have completed the definition of the class, I can create some objects. So I have created two objects and called the same function from the class, and I have used it with the different objects, right? I hope you got the idea. Now, if you can check out this particular diagram, you can relate it. Can you just see that, right? So I have a class, I have created two objects here. Let me just talk about self, although it might be a little complicated right now. But let me just tell you, the self is nothing but the object itself. That's why the name of the parameter is self. What do you mean by that self? So basically, when you call any function using any object, right? So what do? You call it like ob1, which is the object name, not function name, right? And whatever the value that you are providing is given here. Now, when I talk about this value, this is going to be stored in somewhere in the memory, right? So how this value is going to be stored in the memory with the reference to OB1, right? And that is what is nothing but the purpose of this self. So indirectly, when you call a function like this with a value, right, then an object reference is also being passed. So basically, the call is like this behind the scenes. Basically, when you call it like this, you are actually calling it like this. Okay. So OB1, method one. So OB1 is nothing but the object name itself and the value. So every time when you call it, like when you call it OB2, then a self-reference parameter will be passed inside the function and will be received here in the self. Basically, the idea is you need to access the variable name. And the name variable is available in object one as well as object two. And if you have created more objects like this, then it might be different for everything. Now, when you call the function, right, how the function is going to get the value against this. So can you just see, when I call it like object one and method one, I got Ajit. But when I call it object two dot method one, I got Raghav. Are you getting this? So this is basically the idea behind the self. So using self, methods are going to understand or going to know that which object has called me, so that appropriate memory locations can be searched and appropriate values can be fetched. I hope you got the idea about the self, although I have given you a brief introduction to that. Now, coming back to the PPT, and let's check out a couple of more object-oriented concepts, right, in Python. So first thing, I would like to tell you which concepts we are going to understand. First, we're going to discuss the inheritance, right? Then we'll talk about encapsulation, right? And then we'll talk about abstraction, all right? These three are very important concepts in object-oriented programming, which helps you, right, as a developer to develop the programming logics efficiently and with an ease, right? Let's talk about inheritance first, all right? Because it's a very, very important concept in object-oriented programming. All right, when I talk about the inheritance, it's a very simple concept which basically supports code reusability, right? Code reusability. That means whatever we have already defined, can we use it again? Yes, we can do it using inheritance. So basically, the idea behind inheritance is one class can acquire the properties of another class. Now, when I talk about the properties, as I've already told you, there are two things in classes only. First, member variables, and second is nothing but member functions, right? So when I talk about these two properties, right, it can be used in any other class as well. So why we need to use it in any other class? Because see, it is nothing but code reusability. I have defined some functions, some attributes already in a class. Now I want similar features, similar functions in another class. Getting it? So what I can do is, instead of writing it again, I can borrow it from the previous class. So I don't have to write it again. I just have to borrow it from the previous class and I can use it. Now here, the concept is very important, right? And very useful. The class from which I am acquiring the properties is nothing but called as superclass, or you can also call it informally parent class, right? So we have a parent-child relationship here. So parent is nothing but a class from which we are trying to inherit the properties. And the class in which we are trying to inherit the properties, right, is called as subclass, or you can also call as child class to make it easy to understand. Are you getting this? So here, can you just see the father is a base class? We can call it base class, right? And the son is actually derived class. So base class from which we are trying to acquire the property. There are different terminologies used at different places. So super class, base class, parent class, these are the same things, all right? So if I talk about child class, derived class, subclass, these all are again same things, all right? So don't get confused. The idea behind inheritance is nothing but getting the properties of one class into another class. Let me just give you a demo about this introduction to inheritance. Although inheritance is a big topic, but let me just give you an idea about that. Okay, I need to open one more. Yes. So I already have built-in things. You can just see pre-written code here. There are types of inheritance. I am just talking about single inheritance right now. Right? It's not a right time to go deeper inside the types of inheritance. So let's check it out. The single inheritance, or sometimes it is also called a simple inheritance. All right. Here, what am I trying to do? Let me just tell you a scenario. Here, I have a parent class, which is nothing but also a base class. I have already told you, don't get confused, right? So parent is easy to understand, right? So parent class, I have some properties here in the parent class. This is nothing but a constructor. This is called a special function of a class named as constructor of the parent class. Can you just see, I have a parent method. So I have a parent method and a parent class. Now you can just check out, I have defined one more class, right? I have named them parent and child intentionally just to make it even more clear, right? But you can name it anything, doesn't matter, right? Now, what I need to do is I need to derive some properties of parent class into the child class, right? That is what is my purpose using inheritance, no? Now, can you just see, I have defined a child class, and can you just see inside the parenthesis, this is where you define the inheritance, right? So in the parenthesis, you have defined that parent class. Can you just see, you have named a class named as parent. Here, what does it mean by this particular line? This particular line means that child, right, is actually deriving properties from parent. So can you just see, it is really easy in Python, right? Or, some of you might be knowing the concept of inheritance in any other programming language as well. Might be Java, might be C Sharp, might be C++. If you know about that thing, you can easily compare that using the concept of inheritance is very easy in Python, right? As compared to any other programming language which supports object-oriented programming as well, right? You can just check it out, right? It's very easy to inherit the properties. Now, let me just try and demonstrate the inheritance as well. I mean, the complete inheritance. So can you just see, I have a constructor of a child class, right? And I have a child method as well. So you can just see, I have a parent class, I have a child class, and their constructors and functions. Here, can you just see what I have done in this next instructions? I have created objects of parent and child classes. Can you just see that? So this is parent object, which is nothing but object of parent class. Child object is nothing but object of child class. Can you just see that? So here is nothing but child object and parent object. Now, what am I trying to do in the next line? You can just check it out. Parent object is calling parent method, right? Which is pretty obvious, right? We can call the parent method using parent object. We can always do that, no? So what I'm trying to do, I have created an object of this class and I am calling this parent method. Pretty obvious, right? I can do that, right? Let me just run it for you so that you can see the outcome as well, right? Now, can you just see here the parent constructor and child constructor has been called? See, when these constructors are called, when you create an object. So here we created the object. That's why the constructors are called, okay? So just try and understand that. So first I have called the parent method. So can you just see the parent method is being called here? This is parent method. You can just check out. And child object, child method is being called, and you can just check out the outcome. Now, just look into the next line. Now, just observe what am I trying to do. I am using child object to call the parent method. Now, here, can you just check it out? I have a child object, right? And I'm calling the parent method. Can it be done? Yes, we can do that because child is actually inheriting your parent class. So if you can look into this particular line, you will understand how inheritance is going on. You can just see child object is actually calling the parent method. And this is being called. Can you just see that? This is because of inheritance. And similarly, we can call any of the property of the parent class using the object of child class as child class is inheriting the properties of parent class. Now, you must be wondering that can parent object can also call the child properties? No, right? Just try and understand that the inheritance is always unidirectional. What does it mean? That means if child is inheriting the properties of parent, then the child object can use the properties of parent only. When I talk about the parent class object cannot use the properties of child class, right? So let's do that. Can you just see parent object is calling the child method in the last line, right? And you can just see the parent object has no attribute child method, right? This is the error in this last line. You can just check it out because you cannot access the properties of child object, but child object can use the properties of parent. I hope you got the idea about the inheritance, right? Coming to the next part, that is encapsulation. So basically, the idea behind encapsulation is nothing but we bind the methods and the variables into a single unit, all right? It is nothing but encapsulation. This approach of binding methods, see, here variables is nothing but data, right? If you remember the data, it was nothing but name, age, salary. It was data, all right? And the methods are the functions which can operate on that data, all right? So here, what we are trying to do, we are trying to merge the methods that are the functions and the data into a single unit. We call it as class, right? I hope you got the idea behind it, right? This is nothing but class. All right. So you must be wondering that why we need this kind of arrangement. When we club the variables and the methods, right, into a single unit, what we call it as? We call it as class, right? Then your data is actually secured, right? Secure and will not be accessible outside the class. So that is what is the purpose of encapsulation. All right. So we use this encapsulation concept, right, in Python. using access specifiers, right? So using access specifier, and sometimes they also call it access modifiers. All right. So let me just show you that access modifiers. Yeah. So can you just check? We have three access modifiers. Basically, this is the way you achieve the abstraction or encapsulation, right? Let me just tell you, although this is the next concept that we are going to understand, right? So let me just tell you both the things simultaneously. Okay, the abstraction. So let me just tell you that theoretically, then I'll talk about both the concepts simultaneously. All right. If I talk about abstraction, abstraction is nothing but what you do is you hide the implementation details or complex details behind the objects, right? So basically, you are hiding something behind the scene. That is nothing but abstraction. So let me just tell you, abstraction is a theoretical concept. Yeah, you hide the details behind the scene. And how do you achieve the abstraction? You achieve the abstraction using encapsulation. So encapsulation is a practical way, right? And using the encapsulation, we have actually implemented abstraction. We have hidden the data behind the functions, which is there in the class. So these kind of things we can do using abstraction, right? So can you just see, this is with abstraction. You don't know how the engine is working, how the carburetor is working, how the air condition is working with the car, how fuel is being supplied in the car. You don't know anything, right? When you drive this car. But when you open a bonnet, oh my God, you will see a lot of complicated wirings and arrangements of engine. There may be carburetor. There may be a lot of details. But when you close the bonnet, life is very easy, no? So this is nothing but abstraction. So this is with abstraction, you have hidden the internal details, and this is with abstraction that you're showing. So basically, the idea that mechanic can see this complicated details, but a normal driver cannot see that details, right? And that is the idea behind the abstraction. One thing you should always note about the abstract classes, abstract classes, what are the this is nothing but a special category of class, right? So let me just tell you, the abstract classes are nothing but the classes made for inheritance. So we don't want to create an object of that particular class. We just want to inherit it in another class. That special category of class is nothing but abstract class. So can you just see, the abstract classes cannot be instantiated, right? It can only be inherited. Look into that, right? Instantiated, that means we cannot create an object of a class. Can you just see, object of the class? No, we cannot create an object of a class which is abstract in nature. Can you see, abstract class? But we can inherit the abstract class, and you can use that properties of abstract classes into the objects of another class. Thank you so much.